sou Roberta Prescott, estou aqui no canal do Futurecom conduzindo uma série de entrevistas com os principais players da indústria de tecnologia da informação e telecomunicações. Eu dou as boas-vindas a Tom Cloonam, que é Chief Technology Officer na Commscope, e essa entrevista será em inglês. Tom, nice to have you here. Thanks for taking the time to talk with us.
Oh, thank you very much, Roberta. It's very nice to be here, and thank you for the opportunity to speak with everybody today.
What do you foresee as an evolutionary path for the Latin America and Brazil operators in their access networks?
We are really entering a very interesting time for the operators throughout the world. There's a long evolutionary path that's been established for us to move forward into. Both the operators and the vendors are working toward this future that we're moving toward right now. I think operators in Latin America and Brazil can choose from a lot of different phases that have been defined, different phases of time, and they can choose to move in different directions at different points in time, depending on their particular constraints and circumstances that they have. But I think these phases include at least 4 phases going forward as they modify their networks and convert their networks into more powerful networks in the future. I think phase 1 for a lot of the operators will include the enablement of all the DOCSIS 3.1 features that are sitting latent inside of many of the pieces of equipment that are out there. They can turn on OFDMA and OFDM channels to get more spectral efficiencies on their HFC plant to get more throughput. They can move their upstreams to 85 megahertz or to 204 megahertz, which are also permitted by DOCSIS 3.1. They can move their downstreams to 1218 megahertz. All these different changes are available in the products that exist in the field today. So I think a lot of operators will choose to take advantage of those techniques in a phase 1 kind of scenario. Phase 2 sees a lot of the operators moving toward distributed access architectures, remote PHY and remote MAC-PHY. A lot of operators seem to be steering toward remote MAC-PHY right now because it moves a little more of the processing a little bit closer to the edge, creating a form of edge compute for them. So that's getting to be a very popular feature going forward. I think phase 3 would likely be the move toward DOCSIS 4.0, either full duplex DOCSIS or extended spectrum DOCSIS, which permit the operators to move closer to 10 gigabit per second service level agreements. And then phase 4 would probably be the move to passive optical networks that permit 10 gigabit per second, 25 gigabit per second, 50 gigabit per second and higher going forward into the future. As I said, operators can choose to move down any of these paths. They can skip phases. They can combine phases, having multiple phases going on at the same time. So there's a large array of paths that operators can choose going forward into the future as they evolve their network infrastructures.
And how will the operators deliver the new trend in consumptions to have more deterministic services, lower latency, and jitter?
That's a great question. For many, many years, speed was the main topic that we discussed in conferences and inside of cable labs, and most of the operators were very focused on increasing the speed that they could deliver to their subscribers, getting to gigabit per second service level agreements over the last several years. But there is a new focus with the arrival of new applications such as online gaming, virtual reality and augmented reality, automated vehicle control, coordinated multi-point for 5G. All these new applications have created a new push to have lower latency and lower jitter on the HFC plant. And this capability may also help with video conferencing that all of us are involved in, like the session we are sitting in today. So the way that the operators will be able to provide lower latency and lower jitter comes in at least 2 different paths. One of them is to start enabling low latency DOCSIS, which is a set of features that were added into DOCSIS to give some precedence to particular flows of traffic that are deemed to need low latency. So it separates the traffic into 2 different queues, one that's a low latency queue and another one that is a classic queue. It also can do proactive grant services where grants are sent down to modems before they even have the packets to be sent. So packets can be sent through the network much more rapidly. The second path that operators can take is to move toward distributed access architectures, in particular remote MAC PHY that moves the MAC processing closer to the subscriber, maybe being 1,000 feet or 2,000 feet or 5,000 feet away from the subscriber. So the request grant cycles are accelerated in that kind of environment, also improving latency and jitter. So there's a lot of new technologies that are available to the operators going forward to greatly improve the latency and jitter requirements that are needed in the network.
And what is, in your opinion, the path to the convergence between wire and wireless networks in the coming years?
Yeah, convergence is a very interesting topic. And when I talk to different people about convergence, I find that there are many different definitions about what convergence is. It actually can come in many different flavors and can show up in a lot of different applications. It does occur at many layers in the network, and the operators may try to create converged solutions at different points in time. But I think one of the first forms of convergence that will likely show up on a lot of the networks is to have AI, artificial intelligence-based domain controller software suites out there that can manage and monitor the performance of traffic on many different types of networks, whether they're wired networks, whether they're wireless networks, whether they're DOCSIS or PON, whether they're 5G or Wi-Fi. The software suites will be able to kind of steer the traffic to the best location to make sure that the performance on all the different networks, wired or wireless, will work well. But then there's also another flavor of convergence that a lot of people talk about, and that's the flavor that would allow you to utilize wireless networks as a backup for wired networks. So if your wired network ever goes out of service, you can instantaneously switch with very little loss of connection to a wireless network. So that's another form of convergence that I think we will see in the future as a form of high reliability with redundancy in the networks. I think there's going to be another flavor of convergence that shows up where we'll be seamlessly passing packets back and forth between multiple networks, where they could be wired and wireless networks, or between multiple wireless networks. And this is to provide load balancing across the different networks to give the subscribers the best performance available with all the different networks that they might have accessible to them at any point in time. I think convergence may also show up in another form that's been talked about at Cable Labs and some of the committees at Cable Labs. And this is to use the DOCSIS network as means and mechanism to provide backhaul or mid-haul or front-haul capacity to the wireless access points or the base station antennas that live out in the more densified 5G network that we're going to see in the future. So I think all these different types of convergence will exist in the future. And I think different operators will definitely turn on different flavors of those convergence types at different points in time in their networks.
The transition to a more business-oriented services will require a more flexible network architecture and future-proof solutions. What role does the software transformation play in this evolution?
Yeah, software is becoming the glue that really does hold our networks together, and it's the glue that allows us to determine when the networks are working well. It's the glue that allows us to make sure that the networks work well in if there ever is any kind of outage that occurs. So software is key, and it's going to play a major role as we evolve our networks going forward. Software has gone through a lot of changes in the last 10 years. All of them are very helpful. First of all, the use of microservices and cloud-native environments has become a key way to roll out new applications and new services. It's a very cost-effective way to get software into the networks that works well. Most teams now are using various flavors of containers and container lifecycle management software, such as Kubernetes, to bring their software applications up on the servers that they run on. And this allows them to create nicely architected software packages that can be ported from one server to another. And we can instantiate the software processes on different servers very rapidly if there's ever an outage that occurs. So it provides more reliability and more redundancy in the software world as well. Our software teams are using more open source code, so that's allowing us to create more rapid development of new capabilities for the service providers out there to get products out to the field much more rapidly. And also throughout all the standards bodies, there's a lot of well-defined APIs that are being defined. For example, RESTconf, NetConf, and Yang are becoming very popular interfaces that are used between software packages to pass data back and forth between the different entities, the different software entities that work in the network. So all these evolving technologies in the software world are really helping to transform the way that we build software and the way that we can roll out software in a much more rapid fashion. And I think the operators are finding that it provides for a much more responsive type of activity going on between the operators and the vendors. As the operators have issues, the vendors can come out with software packages much more rapidly now using all these different technologies. So it's an exciting world we're moving into, and software is kind of tying it all together going forward.
And another layer on this software transformation is edge computing, right? What role will cloud computing and edge computing play in the networks?
Yeah, cloud computing and edge computing are very interesting. For a while, it looked as if they were competitors to one another, with cloud computing placing the applications up in the cloud on servers, either public or private clouds, and edge computing moving the applications software down closer to the subscribers. But as time has progressed forward, we've all kind of come to realize that there's a nice blend, a nice mix that can and should occur going forward, where we have both cloud computing and edge computing used simultaneously. And you need to place the right applications in the cloud and the right applications in the edge. And when you do that, you get optimal performance. And what we're seeing right now is the nature of the applications that go into the cloud are typically maybe processor intensive functions that have to look over large amounts of data, maybe using artificial intelligence or machine learning techniques to try to ferret out any one-off behaviors or any one-off anomalies that might exist in the network. So that kind of application that takes a lot of data in, maybe looks over data over a long period of time, or looks over a lot of data from a lot of different network elements, that's kind of ideal to place up in the cloud, where you have a lot of processing resources available with multiple servers, where you can horizontally scale your applications across many servers. So there's definitely a need and a desire to use cloud computing in the future. But we're also seeing that edge computing also has a key role in providing optimal services in the future. With edge computing, you move the applications closer to the subscribers, perhaps in a distributed access architecture node, where you might have some processing elements available to do some preliminary processing of the data that's collected. You won't have a large farm of processors like you do up in the cloud. Maybe it'll be 1 or 2 or 5 ARM processors that you have available in the edge and in the node. But there will be adequate processing there, coupled up oftentimes with FPGAs or application-specific ICs that can grab the data as it's passing through, take a look at it, and do some preliminary data captures, preliminary analytics on the data, maybe clean the data up, do some data compression, and then feed that data up into the cloud where the heavy processing is done. So the two worlds, the cloud computing world and the edge computing world, actually serve each other and work well together. And we're seeing more and more applications being designed in the future that will capitalize on both of these technologies and have edge computing doing the anything that requires the functionality to be close to the subscriber, and then the cloud computing can take care of the heavy processing applications that would run further away from the subscriber. So both will definitely exist going forward into the future. It's an exciting time.
Coexisting and complementing each other, right? We are running out of time, but I'd like to end this interview asking you, in your opinion, what do you think is the biggest challenges that operators will face in the near future?
Oh, great question. I'd probably have to say that there's such a broad array of diverse technologies that are becoming available and being used in the networks. Managing those different technologies is certainly a challenge. And, as an example, we have in the DOCSIS world multiple flavors of DOCSIS with integrated CCAPs and distributed access architectures. And we have RMDs and RPDs, and then we have PON and Wi-Fi and LTE and 5G. All these technologies will all coexist in the networks of the future, and the operators will have to manage all of them together. And I think what we just talked about, the software transformation that is taking place and the use of cloud compute and edge compute technologies will help them manage all these networks. That's really going to be one of the key challenges facing them, is managing all these networks in a cohesive fashion. Rapidly diagnosing issues that develop in the networks will be important. And I think going forward, we'll find that artificial intelligence and machine learning inside of those software platforms, whether it's in cloud compute or edge compute, will show up and provide a lot of benefits to the operators to help them manage the more complicated networks with all these different types of last hop technologies that are being used and deployed out there going forward into the future. So I think with that software, we'll be able to make sure that these networks run very well. And that's what we're working on, and what all the vendor community is working on, what all the operator community is working on. I think we're heading into a very, very strong type of solution for our industry going forward into the future.
Tom, thank you very much for sharing with us those insights, and I really enjoyed the time.
I enjoyed it too. Thank you so much for the great questions. Wish everybody to have a very good time at the conference, and we'll look forward to hopefully seeing you all soon, live and in person. That would be wonderful.
That will be wonderful. So soon, I hope. Eu conversei com Tom Cloonam, Chief Technology Officer da Commscope. Eu agradeço também a você que nos assistiu e recomendo não deixar de participar do Futurecom Digital Week, que em 2021 ocorre de 8 a 11 de novembro e traz uma novidade imperdível, o Metaverso 1.0 do Futurecom. Vale a pena conferir. Eu fico por aqui e até a próxima.